Hey, this is Andrew Brown from Exam Pro, and we are taking a look at persistent volumes. So, a persistent volume, or PV, is a piece of storage in the cluster that has been provisioned by an administrator or dynamically provisioned using storage classes. So here is my diagram. And so a PV is similar to a node in that it's a cluster resource, okay? So when I say that a persistent volume does not reside within a node or a pod. And I want to point out that this diagram here is technically not accurate. I just had it as a simplification. And also, while I was learning Kubernetes, it wasn't clear to me that you had to have a persistent volume claim. And only when I did the follow alongs did I realize that you always 100% have to have one. But there are diagrams out there that don't show the PVC, so I thought this was accurate at the time that I made it, but I still left this in just so I could say that this was technically not accurate, and that sometimes you'll see diagrams that do not have a PVC, okay? And we'll talk about PVC in the next slide, so don't worry if it doesn't make sense right now, or future slides here. So persistent volumes are volume plugins like volumes, but have a life cycle independent of any individual pod that uses the persistent volume. So the idea is if the pod goes down, the persistent volume can still remain. It really depends on your reclaim type or how you want to reclaim it. So the API objects captures the details of the implementation of the storage, be that NFS, iSCSI, or a cloud provider specific storage system. Mounting persistent volumes directly to a pod is not allowed and is against the Kubernetes design principles. It would cause tight coupling below the pod volume and the underlying storage. That's why we need a persistent volume claim to ensure decoupling. So there you go.